my talk is circadian rhythms. So Ron Konopka, who was a student in Seymour Benzer's lab, decided to isolate single gene mutations which would impact circadian rhythms. And what they used as an assay was eclosion of the fruit fly from the pupal case. So fruit flies go through a complex developmental life cycle, and before they are adult, they are pupae in cocoons, effectively, and they emerge from these cocoons in a temporally defined way. And they emerge preferentially at dawn, and then the number of flies that emerge subsequently is very low, and then the next day at dawn, a lot of flies emerge, and then very few. And this rhythmic emergence constitutes a 24-hour cycle. And what Ron Konopka and Seymour isolated were 3 mutants which disrupted this normal 24-hour periodicity. They isolated a short period mutant in which the time distance between these emergence waves was 19 hours. They isolated a long period variant in which the distance was 29 hours. And they isolated an arrhythmic mutant which didn't have any periodicity at all. The flies emerged more or less willy-nilly with no apparent rhythmicity. So all 3 of these mutants behaved as if they were allelic, that is, as if all 3 of them were actually mutants of the same gene. And by that I mean that they all mapped to the same location on the X chromosome. This is an illustration of the banding pattern of salivary gland chromosomes, which was described by Bridges, one of Morgan's students. And using genetic crosses, Konopka and Benzer were able to localize all 3 of these variants, the arrhythmic per 0 mutant, the per short mutant, and the per long mutant, to this position, 3b12, on the X chromosome, very near our old friend white, which was used as a visible marker in these genetic crosses. So I now have an animation to give you a flavor for not only the